Okay, this is question 5 from January 2010, Physics 4 paper. Electric fields question starts off with, again, definition. It's a fairly standard way to start. This time it's a definition for the field of force. And a field of force then is the region in which, and you must say the region, not the area, because it isn't an area. It's in 3 dimensions. So it's the region where an object experiences a force. And if it was an electric field, so it's the region in which a charge experiences a force due to another charge. If it's gravitational, it's the region where mass experiences a force due to another mass, etc. State one similarity and one difference between electrical and gravitational fields. So similarity is, okay, they both obey an inverse square law. That's the most obvious. They both depend on two bodies. Okay. And they both define field strength in the same way. Difference then, right? Gravitational fields are always attractive, whereas we know for electric fields can be both attractive and repulsive. Right? So E fields then can be attractive or repulsive, depending on if you have two like charges, they'll be repulsive. If they have two different charges, they'll be attractive. Right, we then have a question which is a sphere of mass 2.3 grams has an electric charge. So we've got a charged mass. It's dropped into a vacuum between two plates. The plates are separated by 9 centimeters and a PD of 160 volts. Right, the question then goes on to ask, calculate the magnitude of the gravitational force acting on the sphere. Well, that's fairly straightforward. That's just W equals mg. Therefore, W is equal to 2.3 grams. So it's 2.3 times 10 to the minus 3 kilograms times 9.81. And when we multiply that out, that becomes 0.0226. So that gives us a gravitational force of 0.023 newtons. That's fairly straightforward calculation, that's why it's only one mark. Calculate the magnitude of the electrical force acting on the sphere. Well, the electrical force is caused by this by this electric field between two plates, and field strength is equal to V divided by D, which is equal to, well, we were told it was 160 volts, and D was 9 centimeters, so that's 9 times 10 to the minus 2. And from that, okay, we can get a value for the field strength. We also know that E is equal to F over Q, therefore F, the force, is equal to E times Q. So that means it's equal to 160 over 9 times 10 to the minus 2 times, and the charge was 3.4 microcoulombs, so 3.4 times 10 to the minus 6. So it's 160 times that 3.4 times 10 to the minus 6 divided by 9 times 10 to the minus 2. Fill in those values and we get a value F equal to 6.0 times 10 to the minus 3 newtons. So 6 times 10 to the minus 3 newtons. Then describe the path of the sphere between the metal plates under the action of both forces. Well, if we go back to the diagram, what's happening is it's been pulled down by, first of all, it's been pulled down by the force due to gravity, and it's also, if it's a positive charge, okay, plus, then it's been pushed by the electric field, which when you combine those two together, what happens is you get something like that, which means that it's moving in a straight line going down and to the right. So describe the path of the sphere. Well, it moves in a straight line with components down and right. Like so. And that's the end of that question.